Hi everyone, and welcome today to my talk, which is going to be about Jetpack Compose. So Jetpack Compose is our modern Android UI toolkit that is all about making it much easier to build UIs. So it's a declarative UI toolkit using the declarative principle for building UIs. It's built on Kotlin, so it really doubles down on the wonderful language features that we know that you love about the language. And it's unbundled, which means it works all the way back to API level 21, and you can get the same consistent experience across all relevant API levels and adopt it at your own pace. You can choose as and when to update versions, and nothing's going to change out from under you, which we love. But for me, the most exciting thing about reimagined UI toolkit about Jetpack Compose is it makes Android UI easier. I mean, I love building Android UIs, but I don't think anyone will claim at this point that it is particularly easy. We think we can do better, and that's what it's all about. So not only do I think it makes it easier, but it also makes the easy things easier. If you ever felt like simple things were too hard, then hopefully we're solving that problem. But almost more excitingly for me is it makes the hard things possible. Often in Android UI, you run up against a brick wall where you couldn't go any further, or you hit a limitation of the system. That we're also trying to kind of break those down to make those things possible for you. So today, my goal is to not just kind of assert this, not just tell you that it's easier, but to actually show you that it's easier. And I'm going to do that by walking you through some samples, some examples of applications that our team has built as part of the process of kind of testing out and giving feedback on the API, iterating on them, and making sure we're building the right for you. So lots of samples in today's talk, samples. We started off last year at the Android Developer Summit with Jet News, one single sample app, which showed a variety of different Compose components and systems. But recently, last August, when we updated it and added a lot more samples, we did 4 new Jet samples to the family. 2 of these, Jet Chat and Jet Survey, are 2 of the more simpler examples. So if you're just getting started with Compose and want to have a look at some simple examples, these are a great place to get going. They show a variety of things like text input and state management and so on, like I've pulled out here. In addition, we added Jet Caster and Jet Snack, a kind of podcast and food ordering app, which shows slightly more advanced theming, as well as some animation and different interaction patterns in there. As well as the Jet samples, we have also built a number of the material study apps. So if you're not familiar, Material Design from material.io has a number of sample apps demonstrating how you can theme material, how you can take the material design system and make it your own, and how to bring your own branding and look and feel. So we've built 3 samples of that, Owl, Crane, and Rally, to show how Compose enables that, how you implement that in Compose. All of these samples are available right now on the GitHub page, so you can right here, so you to check them out. And these are the examples I'll be drawing from today to demonstrate how we think Jetpack makes Android UI. So the first example where I think that Jetpack Compose makes Android UI easier is theming. In particular, the Owl sample app is quite richly themed. You can see different sections of the app have very different color schemes, as well as a variant in night mode as well. So there's kind of 6 different color schemes going on in this application. How does Compose make this easier? Well, as I said before, the Jetpack Compose offers an implementation of the material design system. And in material design, it has this concept of material theming, where you can basically configure the color, typography, and shape parameters, plug those into material design, and get out a set of themed components. So all of the components will reflect those color, type, and typography and shapes. So in Compose, this is very strongly typed and modeled in the composables that we offer. So here's a composable function, one of the major building blocks of UI. And you can see it's a material theme. It implements this material theme idea, and it accepts parameters for those color, type, and shape options. The colors class models that color system we just talked about. So it has name parameters for the different colors of primary, secondary, variance, background, surface, and so forth. It offers builder functions for creating light or dark palettes, so you don't have to specify every single one yourself. You can omit those and get these default, this kind of purple palette you can see here on screen, and just customize the ones that you want to supply. So to build one of those palettes we saw in the OWL sample app, we can declare our colors like this. They're kind of simple Kotlin objects. We can define the colors. And then use one of those builder functions we saw in order to build, here I'm holding it as a top level object, this kind of set of colors, this light, yellow light colors. Typography, similarly, is modeled by the typography class, which accepts a number of text styles. Again, you can omit any that you don't want to specify and get some of the baseline palette and just customize those that you like. And each text style is modeled by this, again, model object called a text style, which is similar to a text appearance from the view world. Allows you to kind of model the font family, line heights, and so forth. And lastly, for shape system, you can create a shapes object, which has categories for small, medium, and large components, used for things like buttons and drawers and fabs and so on. And you can specify different types of shapes. So you can have rounded corner shapes, you can define like set corner radiuses or a percentage, or you can customize individual corner treatments or even use cut corners. So hopefully you've seen that we have this strongly typed mapping to the material system. This makes it like really easy to kind of implement material, and it ships out the box. So then to use this in the OWL system, what we do is we kind of, to centralize our theming, we create this yellow theme composable, which wraps that material theme and configures it. This makes it very easy to kind of make any changes or to kind of centralize any changes you want to make. So to apply this to our UI, so if you had a UI like this, which wasn't using any theme, you would just get the default baseline theme out of the box. And then you just simply wrap it in this yellow theme composable that we just defined, and you can see that all the components have picked up the colors, the typography, the shapes that we specified, like that. What's more, you can also overlay or kind of nest themes. So in this screen, for example, we have this mostly kind of like pink look and feel, but there's this section at the bottom which links out to some related content, which uses a blue look and feel. So you can just nest the themes inside, and any components within that area will then pick up that styling, which is pretty handy. So those things are achievable. I think they are easier in Jetpack Compose due to the strong typing to material that we provide, rather than the view system had a very kind of loosely typed theming system. But I'm also really excited about making the hard things possible as well. So for example, the strongly typeness, like here, you can autocomplete on the available style. So no more having to like dig through XML files to find out what's available. You can kind of just start typing. This is how you access those values you set up, and you can get autocomplete and strong typing to the values available to you. It makes it very easy to do things like create derived colors. So here, for example, I'm taking a copy of the on-surface color and modifying the alpha, which means that if I change that theme color, or have a dark theme, I'll have a derived color, very, very simply. And components can be a bit smarter. They can understand the context that they're shown in and give you better defaults. For example, both the text and the icon composables for showing text and icons kind of use a sensible default for their tint color. So here, for example, the main background, this surface, is setting a background color of primary. So the text and the icons by default will use the on primary color to display, which makes things like supporting dark themes much easier. And what's more, it becomes really easy to understand what colors the components, the material components that we offer use. So no more having to hunt in an XML file to try and work out what theme color a certain component uses. You can just look at all the colors are specified as default arguments to the composable. So here, if I want to see what color does a floating action button, a fab, use for its background, I can just command click through to the component's definition and see right there in the default argument, oh look, it uses the secondary color. So I know what it's using. So if I want to change the theme color, or I can just, it's the default argument, I can pass a different value for the argument when I'm calling it instead. And dark themes become much easier. Like I said, the color theming is just a set of colors. So we have, this object holding a bunch of light colors, and we can define an alternate one holding a bunch of colors to use in a dark theme, dark colors. And then in my theme composable, I can just pass a Boolean parameter as to whether or not it should be, wanted to display in dark theme. Here I'm defaulting it to a query from Compose as to whether the system is running in dark theme, but you can pass a different value into this from wherever you like. And then supporting dark theme is as simple as an if statement. So if I want a dark theme, use this dark set of colors. Otherwise, use this light set of colors. And then there's nothing kind of like specific to dark theme kind of built up. It's just use one set of colors or another. So that was definitely much easier to do those things than I think in the view system. But it also enables some really quite exciting possibilities. One of which is dynamic theming. So this sample here is the Jetcaster sample, which is a sort of podcast application. And you can see as you swipe through different podcasts at the top in the carousel, it's pulling out colors from the album art and using that to theme the UI. So you can see like the tab indicator and the kind of technology button there is changing color. This was like incredibly hard to do in the view system. You couldn't create themes dynamically. It was all tied into precompiled steps that had to be done at build time, not at runtime. So it was nigh on impossible. The way you do this in Compose is we use the existing palette image to look at the album art and extract a dominant color. And then what we do is we take the existing color set that we had and we take a copy of it and change the primary color. We even animate this change with this magical animate call here, which I'll come back to if you bear with me for a little bit. And then we just wrap the content in the material theme with this updated color set. And that's it. You've dynamically derived the color, even animated the change between them, and created this dynamic theming quite simply, which is amazing, I think. You can even do cool stuff like testing theme changes. So in this example here of changing between light and dark theme, in our tests, we set up a state flow as to whether or not you should be in dark theme. And then we pass that into our theme when we're setting it up. This collector state function here is basically an observe call. It'll observe that state flow and re-execute this code if that value changes. So then in our test, what we do is we kind of manipulate and assert about our UI, and set it in a certain state, and then we change that state flow. We update the value to say now go into dark theme, and then the UI will then invalidate, update, recompose as we call it, and then we can assert about it again, to check it's still in the right state, or even take a screenshot and compare that against a golden or something like that. So this was pretty hard to do before. And one thing I'm really excited about, while Compose ships an implementation of the material design system, and we think it's very good. There's not about it. It's kind of built on top of public API, and you're free to extend it or you create your own as well. So if you want to create your own custom design system, it's entirely possible and intended to be done that way. One of our samples, the JetSnack sample, actually has a custom design system. So you can see it uses a different color system than the materials kind of primary, secondary system, so forth. In fact, the color system uses a heavy use of gradients throughout the UI as well. And it comes together in this kind of custom color palette, which is very different than the material one. So this is a sample screen from the sample app, the JetSnack sample. And you can see here, for example, things like the button at the bottom uses a gradient, which isn't something that the material button supports out of the box. That's not part of the material specification for a button. So how would you go about supporting this kind of thing? Well, we kind of do the same thing that material does, but you kind of build your own version. So instead of using the materials colors class, I create my own JetSnack color palette class where I have named properties for each of those kind of semantically named colors in my color system. And you can see I'm using lists of colors here to model those gradients. I can't just pass my own custom class to the colors parameter of the material theme because, as I said, it's strongly typed. It doesn't understand my type. So what I do instead is kind of do the same thing the material does myself. And there's kind of 3 steps to this. First, you hold the colors somewhere in what we call an ambient, and then you provide a value for that and then use them. So wait, I just introduced quite a few concepts here. Let's walk through those one at a time. First up, what is an ambient? Well, normally in Jetpack Compose, data flows down through your UI from the top level as parameters to the function. So they're kind of like almost like pure functions where you give it all of the information necessary to render. That can, however, be very cumbersome for things which you use throughout the place. Imagine if you had to pass every single color or every single text style that you use from the top level all the way down to every single leaf node where it's needed. And as such, we provide this concept of ambience, which is basically a service locator. So it's a way to name an object and be able to retrieve its value later. But ambients are also kind of tree local, so you can actually provide different values for that service locator kind of property at different levels in the hierarchy, so that you can create like theme subsections. So the way you create an ambient is just like this. You just say ambient of and then the type. So here I'm defining this ambient, kind of like this named ambient, this Jetsnack colors thingy, and saying right now, and I'm giving it a default value. So by default, I'm setting a light color palette. And then to provide a value for that, a different value for that, you use the providers composable. And there you basically say, for this Jetsnack colors ambient I just defined, please set this, this set of colors. Interestingly, you can see I'm actually using my custom color system in combination with material as well, because I'm not defining my own typography or shape system, so it can kind of work together. So I'm defining my own color system, but not my own typography and shape. So I'm using both of them here. And then in my, if I want to retrieve the kind of colors, my custom color palette, I've wrapped in an object to make it a little bit easier and mirror how material does it. But the essential thing is I call the ambient name .current, and that will return back to me the value for that position in the tree where your UI is right now. So then in my application code, if I want to grab one of my theme colors, I just do this Jetsnack theme.colors, and then I have this strongly typed object where I can read back the colors. So if I want to create my own button with gradient support, as I said, the material button doesn't do that. But what I can do is I can actually copy the implementation of materials button and alter it to create my own button. So you can see here the default button that we ship accepts a single color for the background. But that might sound a bit scary, like taking the button class and pasting it into your own code base, forking it essentially. But Compose, as it's named, is built up by composing together building blocks of other functionality. So the button class itself is actually only about 30 lines of code long, and it's essentially built up of three things. It's made up of a surface, which does things like drawing the background and so forth, a text style provider, which defaults text inside to be the right style, and a row to accept the contents of the button to kind of hold it. That's it. That's all the button is made up from, about 30 lines of code. So if we want to change its functionality, we essentially fork it, we kind of copy it, and then we create our own Jetsnack button here. And instead of a single color, I'll accept a list of colors, and here I'm defaulting it to that value from my custom color system here, the interactive primary one. I don't want the solid color, the background, so I'm actually going to keep the surface color but set it to transparent. And then I'll draw the gradient myself. And the way you do that is with a modifier, which again, I'm going to come back to in a little bit later. But I use that to draw the gradient that I wanted. And it's really like this design, which I think is really powerful about Compose, that you shouldn't really think of it as a single monolithic thing. Compose is actually designed in layers. So we start on the runtime, which has a UI layer, and then foundation, which is kind of design system agnostic building blocks to build UI, and then material, which is a highly opinionated, strongly typed design system. And you can kind of pick and choose from the layers as you need. So if you're happy with a very material app, then use material. If you have a custom design system, then which is different from material, then you can build it on top of material, or you can not use material at all and just use the lower level primitives and kind of build your own. And within each layer, the same principle applies. So materials button component, for example, itself, as we just saw, is built up from other building blocks, from material surface and then the text providers and a row. And you can build your own on top of these same primitives as well. Or you can eschew the material system altogether and build your own button, not using any of the material primitives at all, using kind of lower level things like boxes and so forth. Cool. So that was the first example where I think Compose was super interesting. Next up was layouts. Like this is UI toolkit, and the samples we built had a variety of kind of complexities, from login screens to forms to very custom things like this staggered grid here. The very simple building blocks are very easy to use. We found, like, columns for laying things out vertically, rows for laying things out horizontally. Those two are a bit like linear layouts from the view system. A box, just a bit like a frame layout for potentially overlapping content. You even have my beloved constraint layout, and I actually really like the DSL, the domain specific language you use to configure the constraints. It's really great. So these were kind of sufficient for building it, and what's great is you don't have to worry about too much nesting anymore. It just isn't a problem in Compose. But there were some other aspects of layout which actually were much easier in Compose, we found. The first one was building lists. So if we take a look at this screen from Jetpack again, it's kind of, you can see we have this horizontally scrolling list of popular snacks. So you can imagine in the view world, this would be a recycler view with a XML layout for each item, and an adapter to bind it all together and so forth. But in Compose, this is the code. This is all the code to render that, basically. We have this component called lazy row for. Lazy basically means, like a recycler view, it's windowed, so it'll only render the items that you need on screen. So as it kind of goes off screen, it'll free the memory and so forth. So you call it lazy row for, and you just pass it the list of model items, my list of snacks, and then you get a callback. So here it'll pass you back each one, like how to render each individual item. And so I'm rendering it with this snack item here. That's it. No adapter, no multiple files to try and span and keep track of. It's just super simple to render list components. It gets even better. This screen here is actually a list of lists. So it's a vertically scrolling list with horizontally scrolling lists within it. What's more, there's multiple different item types in this list. So there's these kind of filter objects at the top, and then a number of these horizontally scrolling snack collections, I call them. So again, if you were to implement this in the view world, you'd probably be thinking about, okay, so I need a different item types in my recycler view, or use some kind of like concat adapter or something to plug them all together. Rather than the lazy for, like lazy column for or lazy row for, there's actually an alternate version called lazy column here, which actually offers a scope with different ways to kind of add content to this. So here I'm using this lazy column, and then you can define, the scope exposes these methods like item, where I can define a single item. So here I'm adding that filters bar, and I'll add that single item to the kind of scrolling content, or items method, which accepts a collection of model objects. So similar to the example before, we give it that kind of list of snacks, and it will pass them, you'll get a lambda block where you can then render each item here. So it becomes super easy to add together this kind of different item types just with blocks like this. And a little sneak peek, we're working on a header object. It's not quite available just yet, but this is going to implement sticky headers as well. So you can have something kind of like a stick to the top when it reaches, and then scroll out when the next kind of header item comes into view as well. It makes it so much easier. Can you imagine what building the code for building this kind of interleaving these kind of different item types in recycler view would look like? It would be much more complex. Another area which we found really great with Compose, is this idea of modifiers, which is how you actually configure or decorate each of the individual layout items. So what's a modifier? To kind of walk you through, understand what it is, let's go back to kind of some of those sample layouts we saw before and build a simple list item. So something like, a photo and 2 lines of text. So this is essentially modeled as a row to lay things out horizontally, with first an image and then a column to stack these 2 items of text. But if you were to just render that, you'd get something like this, where the image is too big and they're not aligned and so forth. And that's where modifiers come in. Modifiers are kind of similar to layout params from the view world, but with superpowers, so as we'll get into. So first off, all kind of UI composables accept a modifier parameter, where you can use the capital M modifier object in order to kind of discover what's available. So here I'm specifying the image wants to be 64 by 64 dip. Then on the column itself, I can use a padding modifier in order to move it away from it. And then if I want to align that vertically, and then I can use the center vertically modifier. You can see here that the modifier is actually kind of a chain, using like a fluent syntax, so you can just append it, so dot padding, dot align, in order to kind of compose their behaviors together. What's really great about modifiers, I think, is that they're type safe. So rows lay out their content horizontally. So an alignment only makes sense to align vertically because the row is positioning things horizontally. So that's the only thing that makes sense. In the layout params XML world, you might have, blindly try to apply different layout params, not sure if it's gravity, layout gravity, and so forth. But row actually exposes the valid alignment as an extension function on its scope, on row scope. And as such, you can't pass a horizontal alignment to something within a row. It just won't compile. So the strong typing gives you like lots of safety and kind of like helps you only discover what is applicable to an element. You don't have to just blindly try stuff and see what works. It's not just for layout, you can also affect things like drawing. So on the image, I can apply a clip modifier in order to kind of like clip the corners and round them off like that. I can apply some padding on the kind of outside of the row itself. And then if I want to draw a background, I could use the background modifier. But this might be surprising. If you're expecting this background to kind of apply to the entire row itself, this kind of maybe will catch you out at first when you start writing Compose, but the key here is that the order of modifiers is significant. So because we have the padding first, then the background, that's the order of operation. So the padding is applied and then the background is only drawn within the padding. If we want the background to apply to the entire row, not just including the padding, then we just switch the order. And at first I thought this was a bit of a kind of a gotcha, like, oh, this is a bit annoying. But actually now I love it because what it means is it's entirely within your control, the order to which operations are applied and what that means. So it's not down, you don't have to like learn some intrinsic behavior of, oh, hang on, backgrounds are drawn first, then paddings, like the box model. Instead, it means that you can control the behavior by, just like any other method call in our code, the order is significant. Which means that if I want to put some space around the outside of this element, some margin in the odd parlance, then I can just use a second padding modifier to put that space around the outside. Or if I want to make the item clickable to interactive, then you can use the clickable modifier. And doing it before the padding means that the outer spacing will be clickable, or and the ripple that shows because of it will also extend to that area. Or if I want it to not include the outer margin, I can just change the order like this. You're in control, and it's kind of entirely deterministic. So the way you kind of think of modifiers is you read them as this kind of ordered chain. So you think first apply some spacing around the entire element, then make it clickable, then draw a background, then add some spacing on the inside, and then go and do the contents. So that was a pretty simple modifier chain, but you can see it's quite powerful here. You can add behaviors to each of your elements in your UI. And modifiers, there's pretty much no limit to what you can do. You can make something like toggleable, or even add scrolling to an element with just a single modifier like this, or even make something zoomable. There's some really, really powerful higher level behaviors that you can just add into your components quite simply. And each of these modifiers is kind of responsible for one thing. So it's kind of like single responsibility principle. So we use the modifiers throughout our samples, everywhere really. And one element where I think it really shone is like building a custom element. So here, for example, one of these search categories or whatever it is, you can see it builds up quite a chain of set an aspect ratio, draw a shadow, then clip, and then draw a horizontal gradient and make it clickable. You can define a lot of behavior very, very simply in this modifier. But this element also shows something which I think is also really powerful about the layout system, which is how easy it's become to create a very custom layout. Creating a custom view, custom like layout and drawing was kind of a high bar to cross in the view world. It involved a lot of boilerplate and a lot of getting things right, but Compose has really lowered that barrier, I think. So this element had a particular design. My design called for the text should take up a certain percentage, then the image should kind of peek in with a certain percentage size. And that image should have like a minimum diameter of like 140 dip or something like that. That's what the designer asked for. So you might have been able to use a combination of the standard layouts to build this, but it's actually super simple to do this with a custom layout. So in Compose, layout is a function, everything's a function. And the layout composable is what rows and columns and constraint layout and everything uses under the hood to do their own layouts, but you can and should use it yourself to build your own custom layouts. So let's walk through how you do that. So it accepts a content block, which is the content to show inside it, and a modifier in order to be apply those modifiers that we just went through. And then you have to provide a measure block, which you normally which has a responsibility to measure those items, the content, call layout, which is where you report your size, and then place each item on screen. Let's walk through an example of doing that. So I'll create my own custom layout like this, and then I'll implement that measure block as a trailing lander. So to implement that, you get passed in a number of measurables and constraints, and you're responsible for measuring and placing them. So what are those things? So measurables, constraints first. So you'll get passed in this constraints object, which basically is your parent telling you how large or small you can be. And it passes you a minimum and maximum width and height. And you have to respect those. That's the kind of incoming constraint saying, this is how big you can be. The measurables are basically the contents, the items that you're trying to render within your custom layout. And basically, it's a measurable has one main method, which is measure. So for each item, you can ask it to measure it for a given set of constraints, which we'll come back to in a second. And you'll get returned this placeable object. So let's walk through an example. The first responsibility I said is you have to measure each item. So in a very simple implementation, you can just map over them, and for each one, just measure it with the incoming constraints, just not change them. But this is where you can and should alter the constraints. So this is where you actually apply your layout policy or logic, or how you want to lay things out. Then you get given back these placeable objects, and the placeable basically reports back for width and height for how large it wanted to be, and then has a single place method where you place it in XY space. Cool. So your next responsibility is to call layout. So this is where you report how large you actually want to be, given that you've kind of measured all your children and so forth. So you call back with the width and height you'd like to be, and then place each item. So we can iterate over those placeables, and for each placeable, we can call place for a given XY coordinate. So that's the theory. Let's apply it. If we want to build this item right here, we model this as this search category composable, and that holds a layout which uses the modifier chain we saw before in order to kind of draw the right size and to clip and so forth. And then I kind of hard code, I say I always want to pass into my contents some text and my image here. And that's the interesting bit. So to implement the custom layout logic. So I'm passing these measurables and constraints, and I said that the text wants to be 55% of the width. So I can just calculate that. I can just say for my incoming constraints, the maximum width the entire item can be, just times it by 0.55, and that's how wide the text can be. And then what I do is I just measure it. I call measure with a fixed width. I set create a version of these constraints with a fixed width. And then I do a similar for the image, where I basically said it wants to be a minimum of 140 dips. So I grab I say measure it as exactly 140 dip like that. I can then call layout function. Here I'm not actually changing my size. I'm just accepting the incoming size. So I just pass those back up as my width and height, and then call place on the item. So here I place the text on the left, and then I center it vertically like this. And then for the image, I place it to the right of the text by setting its left coordinate to the width of the text, and also center that vertically. And so like this, it was really simple to achieve the exact layout that I wanted. With a small amount of maths, you can achieve the exact layout that you wanted. One thing I love about the design of the Compose's layout system is that it actually prevents you from doing some things. If you try to measure a measurable twice, it'll actually throw an illegal state exception. We don't let you do double measurement. And as such, you get some kind of performance guarantees. We know that you can't get into excessively costly measure cycles. One of the kind of complaints with the view system was, you could nest layouts and get into very expensive measure cycles, which we just stop you from doing. And as such, you can do different things. So in this example here, where as I'm scrolling, I'm changing the position and size of an element. This is entirely implemented as a custom layout. This would be, prohibitively expensive in the view system, but it's just how you can very simply do it. So I keep track of the scroll, how far this scroll variable is changing. And given how much that scroll over a given range is, I calculate this kind of collapse fraction. I then use the lerp function to linearly interpolate, to kind of go between one value and another for the image size and its position. And then what I do is I just use those values in measurement. So I just set the constraints to be that given size based on how far you've scrolled and measure it at that size, and do a similar technique for how far you scroll to place the element between the start and end position, and then just place the element accordingly. You can even animate those changes. So in this example here, the bottom nav item is kind of growing in width and changing in position based on which item is selected. So this is all done in layout. You basically I have this kind of selected fractions, which is basically a list of 0 to 1 of how selected an item is. And you basically can just based on how selected that is, you can just animate that. You can just lay out with a different width based on that selection fraction, and then measure and lay out accordingly. Cool. So layout was much simpler in Compose, I think. Another area where Compose really shone, I think, was animation. Going back to the owl example on the kind of the onboarding screen, we have this element where you can select these kind of topics here, and we wanted to kind of round the corner and do some stuff like that. So to round the corner, you're basically saying if it's selected, use this corner radius, otherwise use a 0 corner radius, and then use that radius to apply it to the shape of each item. Now, if you want to animate that change, and so doing it statically, it's as simple as this. You just wrap that call in animate. And now that anything that reads that radius value, that radius will now be animated between those two values, and anything that reads it will get recomposed, reinvalidated, and redrawn throughout the animation while it's changing. Super simple. So that's the kind of the single value animation API, which is just like the easiest animation. Is criminally easy how easy it is to animate things. But we actually wanted for this example a slightly more complex animation. We're going to round the corner, I'm going to fade in that check mark and the pink overlay and so on. So I actually switched it to an alternate API to use something called a transition. So transition is for animating groups of properties together. So the way we do this is you set up a prop key for each property that you want to animate, and then states for each state you want to animate between. Here I'm using an enum with just 2 states, selected and unselected, but you can have as many as you need. And then you create what we call a transition definition, which is basically for a given state. So here for the selected state, use a property setter syntax to say that this is what each of those properties values should be. And then you can use the transition composable to get the current state. So use this definition, and for this given state, what should my current values be? And I get back this selection state with the current values, as it were. And then you can use property getter syntax to extract out the current values. And again, so if you change the given state, these values will all animate and everything will just update nicely. And you use those in your drawing. And one of my favorite things is by default, the animation system uses a spring-based, physics-based system. So everything is beautifully, smoothly interruptible. So you can kind of hammer on the animation and it will slow down and speed up back to the next state, all out of the box. You can also define tweens if you want to, get very specific about the interpolations and so forth. Another area of animation that was much easier was the tooling story as well. So the Android Studio preview offers this animation preview, which lets you, for any transition you have set up, you can preview it like this. So you can see I can slow it down and really kind of get into the details of the animation. I can change the states I'm animating between. Well, my favorite thing here is you can actually grab the kind of the seek bar and scrub through an animation and really dial in the values to make sure you're building exactly the right animation. Super cool tooling story there. So not only did it make animation way easier, but also made some things possible. For example, you can now test animation. So in this rally example, it has this kind of a graph which is animated, which is kind of this hero element, and we wanted to test it. So you can do so by accessing the in your test role. You have the clock test role. It has the ability to kind of pause or advance the clock, and this is the clock that will drive all animation. So you can manually control the animation's progress. So, for example, in that test, we grab from the rule and pause the clock, and then we kind of manipulate our UI into a certain state, and then we can advance time. So we can advance the clock by a certain time to where we know it should be within an animation, and then do something like assert about it, or even capture a screenshot, capture a bitmap of the state of the UI at that point, and do something like compare it to a golden image, which is this was pretty hard to do. Cool. So hopefully today I've shown you through all of our samples that Compose makes the easy things easy and the hard things possible. It makes Android UI so much easier. If you want to get started learning or go further with your journey of learning Compose, then you can find all the samples on GitHub or at this short link here, as well as we have a number of code labs and documentation to kind of help you learn further. Compose is in alpha, so we don't recommend shipping to production just yet, but we do think it's right now is the right time to give us feedback. Like, Compose is coming. It's going to be our recommended UI toolkit for the future. Now is your chance to help us shape it. So play with it, see if it meets your needs. If there's anything that you'd love to see changed, let us know. Now is the time. So you can file issues at this link here, or come talk to us in the Slack channel. That's what I got. Thanks for having me.